In this video, I'll demonstrate how to use a graphing calculator to solve the polynomial inequality 2x cubed minus 2x is greater than or equal to 3x squared minus 3. The first step is we need to get one side of that inequality equal to 0. We can do that by subtracting 3x squared and adding 3 to each side, and so that would give us 2x cubed minus 2x minus 3x squared plus 3 is greater than or equal to 0. So now we want to use a graphing calculator to graph this polynomial 2x cubed minus 2x minus 3x squared plus 3 and find where the graph of that is above or on the x-axis. Since that's what it means to be greater than or equal to 0 there. So the first thing we want to do is get out our calculator and go to the y equals screen and input the polynomial 2x cubed minus 2x minus 3x squared plus 3. Then we're going to graph the polynomial, and when we graph this in a standard window, notice that we can see the zeros of -1, 1, and 1.5, which we found algebraically on a previous video. We know from previous videos that it should dip down there. It's a little hard to see, and when I say dip down, it should dip below the x-axis between the 1 and 1.5. So what I can do is zoom in by resetting my calculator viewing window. I'm going to press Window, and I'm going to use -4 to 4 as my x-min and x-max because all of my zeros are between -1 and 1.5. And for my y-min and y-max, I'm going to use -4 to 4. Again, my highest point on the graph looks to be around 3. And then when I graph that, I'm zooming in on the calculator so I can see now clearly that the graph does dip below the x-axis between the 1 and 1.5. I need to figure out where is this graph above the x-axis, and it is above the x-axis between the zeros of -1 and 1, and then to the right of 1.5. Again, if you were doing this on a new problem, you would have to solve the associated equation by factoring or some means and know exactly what the values of those zeros are. But I know that the zeros are -1, 1, and 1.5, and I know that the graph is above the x-axis between the -1 and 1 and to the right of 1.5. So that would tell me my solution set is -1 to 1 with the brackets and bracket 1.5 to infinity. The other thing I can do on my calculator is I can look at the table, right? Remember on just the algebraic way is we plug in x values from those regions that result from the zeros, and the table can actually tell me what those are. I see here on the table that between -1 and 1, my value of y is 3, which is greater than or equal to 0. So that's a place where solutions occur. And then to the right of 1.5, like 1.6 on up, notice that my y values are positive. So again, that's what I'm looking for, is what x values have a positive y value. I can do that by looking at the graph or by looking at specific y values for chosen x values. In any case, the solution is -1 to 1 with brackets union 1.5 to infinity.